All right, welcome to The Explainer. Today, we're diving into a piece of hardware that solves a problem you probably didn't even know existed. A problem that comes from creating just a staggering amount of data in some of the most remote places on Earth.
So let me start with a question for you. What happens when you're out in the middle of nowhere and you're generating more data than any network could possibly handle? And I'm not talking about your home Wi-Fi struggling with a 4K stream. We're talking terabytes upon terabytes of information flooding in from drone swarms, sensor grids, or mobile labs.
You know, there's actually a name for this problem in the industry. They call it data gravity. It's this idea that a data set can become so enormous, so heavy, metaphorically, that it's just physically impractical to move it. Trying to upload it to the cloud would take weeks or cost a fortune. The data basically has its own gravity, and you can't escape it.
So how in the world do you solve that? Well, if you can't move the mountain to Muhammad, the solution is as elegant as it is powerful. You don't move the data to the cloud, you bring the cloud to the data. And you do it with this incredible piece of engineering called the RIOS Pilot AI Core.
Yeah, they've nicknamed it the sovereign brain. And honestly, that name is perfect. Just imagine a completely self-sufficient mobile data center built inside a standard, rugged shipping container. It's designed to be dropped anywhere on the planet, run completely off-grid, and bring supercomputing power right to the front lines, to what they call the tactical edge.
Now, to really get what makes this thing special, we need to quickly talk about the difference between using AI and creating AI. Using a pre-built AI model, like having a camera that can spot a license plate, that's called inference. That's what these smaller Scout units do. But the AI core is built for the really hard part. Training. That's the heavy-duty, power-hungry process of building an AI model from scratch or teaching it new tricks with new data. That's the sovereign's mission.
Okay, so what is actually packed into this data center in a box? Come on, let's pop the hood and take a look at the engineering that makes this whole thing tick. So it all starts with the shell. And let me tell you, this is not your average shipping container. Think of it more like a portable, hardened vault. We're talking reinforced steel doors, biometric access controls. You can even get it with RF shielding to turn it into a true Faraday cage, completely isolated from outside signals. Maximum security.
But of course, to run a supercomputer, you need a serious power source. The designers call this part the reactor. The whole thing is built around a power-first philosophy. It has these massive deployable solar wings that fold out and literally triple the surface area for capturing sunlight. All that juice flows into a huge 60 kilowatt-hour industrial battery bank, which is more than enough to keep the entire system running 24/7.
Okay, and at the absolute heart of the machine is the brain. And no, this is not your souped-up gaming rig. This is proper data center-grade silicon. We're talking dual Intel Xeon Platinum processors and, the real star of the show, the NVIDIA A100 Tensor Core GPU. That GPU is the muscle, the heavy lifter that's absolutely essential for training complex AI models in the field.
Naturally, all that processing power generates an incredible amount of heat. So how do you stop it from melting down in the middle of a desert? Well, with an industrial-grade redundant cooling system. It uses the same hot aisle/cold aisle design you'd find in a massive Google data center to manage airflow. This thing is built to run at full tilt, without throttling, even when it's 50 degrees Celsius. That's 122 Fahrenheit outside. Just wow.
So the hardware is obviously super impressive, but the big question is, why? Why go to all this trouble to build something like this? What is its actual job out there in the real world?
This is where it all comes together, in something called the local learning loop. It's a really brilliant concept. As you can see, it's a three-step cycle. First, you've got smaller devices in the field collecting data. When they encounter something they don't recognize, what they call a hard case, they send that data to the AI core. Then, overnight, the core uses all those hard cases to retrain and improve the AI model. And finally, in the morning, it pushes out an over-the-air update. So every single device in the network gets smarter every single day, all without ever needing an internet connection to the outside world.
So what does that actually look like? Well, for a sovereign nation, it's an instant, secure data center that guarantees citizen data never leaves its borders. For a mining company, it means processing seismic data right there on site, turning weeks of waiting into just a few hours of work. During a disaster, a command post can run complex flood or fire spread models on the fly. For these highly specific but totally critical missions, this thing is a game changer.
All right, let's talk money. What does a sovereign supercomputer in a box actually cost? Now, the price tag might make you blink, but the real story here is the value it delivers.
The target price is $185,000. And I know what you're thinking. That is a lot of cash. But hang on, before you get sticker shock, let's break down what that number actually includes.
See, that number on its own is pretty misleading. The right way to think about this is as infrastructure replacement. I mean, look at this table. If you wanted to build a permanent facility, you'd be paying maybe $100,000 for a small concrete building, at least $50,000 to get connected to the power grid, plus a backup generator, plus all the IT hardware. You're easily looking at over $230,000. This box includes all of that for less. And, oh, by the way, it's mobile.
So the real return on investment here, the real kicker, comes from three things. First, bandwidth costs. Trying to upload 100 terabytes of data from a remote location via satellite, that alone could cost you over $100,000. Local processing is basically free. Second, security. You have total physical control of the hardware. And third, maybe the most important, speed. It reduces the time it takes to get from data to an actual decision, from weeks to just a matter of hours.
Internally, this is what's known as a halo product, and it's a perfect description. Think of it like a concept supercar for an automaker. They might not sell a ton of them, but its very existence proves the company's engineering chops. It's the flagship that makes you say, okay, these guys are the real deal.
Ultimately, the RIOS AI Core really represents a whole new class of infrastructure, one that isn't tethered to a power grid or a fiber optic cable in the ground. It's a system that lets us ask a really profound question. If you can bring the brain directly to the data, no matter where on Earth that data is, what problems, once thought to be impossible, can you finally solve?